We pull these glass rectangles out of our pockets dozens of times a day, usually treating them as a single solid object. But under the screen, hundreds of distinct components are packed into a volume that, a century ago, could barely house a single electrical coil. Making this density of technology function required a specific sequence of engineering problems to be solved, one layer at a time. To see how we got here, we have to perform a kind of technological archaeology. If we strip away the modern layers, peeling back the glass, the lithium-ion battery, and the silicon, we eventually reach the absolute base function, a pure signal wave moving through the air. Tracing that signal takes us back a century, to an era when simply capturing a voice from the air required an industrial-scale operation. In the 1920s, wireless voice transmission relied on scale. To pull a basic audio signal out of the atmosphere, you needed sprawling walls of hardware and massive coiled electrical machinery. Every step of the process was fragile. Manipulating the electrical current meant using large, exposed glass vacuum tubes and heavy manual dials to find the right frequency. Because the receiving equipment was so large, the user was entirely physically tethered. Even the mobile part of the system, the candlestick phone, was a heavy brass object anchored to a desk by thick wiring. For the telephone to evolve, engineers first had to solve a weight problem. They needed to find a way to move away from these heavy industrial metals. The mid-20th century introduced a new manufacturing logic for the telephone, centered on the rise of synthetic materials. Designers replaced heavy brass and wood with molded plastics. This allowed them to consolidate separate heavy metal components into a single, lightweight shell with an integrated rotary dial. Because plastic could be molded into precise, identical shapes, factories could move towards rapid mass production. The telephone became a common household fixture rather than a specialized tool. While the 1950s solved the problems of weight and scale, the internal logic of the machine was still strictly analog, a limitation that only the introduction of computing could address. By the 1990s, the telephone began to function less like a simple transmitter and more like a computer. This era marked the transition from processing sound as a continuous analog wave to processing it as discrete digital data, a stream of ones and zeros. This digital shift was visible on the device itself. For the first time, liquid crystal displays were layered onto the phone to show text and numbers. This data-driven approach allowed integrating cellular networks, using external antennas to finally remove the cord. As microchips grew more efficient, the hardware shrank. The sprawling machinery of the 1920s was refined into a device that could fit inside a pocket. To maintain a functional interface on these smaller frames, designers used physical covers and flaps to protect keys while maximizing the available space for input. The 1990s essentially turned the telephone into a processor of information, setting the stage for the multi-purpose tools we use today. Today's smartphone represents the culmination of a century of historical layers stacking on one another. Modern processors compress these previous eras into an area smaller than a fingernail, running digital systems perfected in the 90s inside housings inspired by the 50s. By integrating components that didn't exist in the original design, like microscopic camera lenses, precise GPS sensors, and constant internet access, the hardware has moved beyond its original role as a voice transmitter. Every time we use one of these devices, we are interacting with a century of human problem-solving, all compounded into a single slate of glass. The smartphone in your pocket isn't a single invention. It's the result of heavy metals, plastic assembly lines, and digital awakenings working in unison.